Hello and welcome to Algebra 2 Test Section 1 on exponential functions. All right, so we just want to solve each equation. All right, so for the first problem, we're going to look at 5 raised to the power of v plus 2. This is equal to 25. So to solve this equation, what we want to do is we want to have the same base on each side of the equation. So on the left, I have a base of 5. On the right, what could I do to rewrite 25 as a number in exponential form where the base is 5? Well, 25 is just 5 squared, so I could just write 25 as 5 squared. So now the equation would be rewritten as 5 raised to the power of v plus 2, and this is equal to 5 squared. So I have the same base. And the rule for that is if you have the same base, basically you can just take the exponents. So here the exponent is v plus 2. Here the exponent is 2. You can set them equal to each other, and you can just solve. So in other words, this would set up the equation v plus 2 is equal to 2. We would solve this guy. We subtract 2 away from each side of the equation, and you get that v is equal to 0. Now, you can check these. I'm not going to check all of them, but you can check these by just plugging in and verifying that the left and the right sides are equal. So let's check this guy. So if I plugged in a 0 there, I would have 0 plus 2, which is 2. So you'd have 5 squared equals 25, or 25 equals 25. So that does check itself out. So the solution here is v equals 0. Of course, if you wanted to write this in solution set notation, we could put a 0 inside of set braces. All right, let's take a look at another problem. So suppose you see 3 raised to the power of 2x minus 3. This is equal to 3 raised to the power of negative 3x. So in this case, we have an easier example. Essentially, all we need to do is just take 2x minus 3 and set it equal to negative 3x, right? Because we already have the same base of 3 in each case. So you would have 2x minus 3 is equal to negative 3x. And then we'd solve this guy for x. So let me add 3 to each side of the equation. And let me add 3x to each side of the equation. And so this would cancel, and this would cancel. So 2x plus 3x is 5x. And this is equal to 3. Divide both sides of the equation by 5. And we'll see that x is equal to 3/5. Or again, in solution set notation, we just put 3/5 inside of set braces. Hello and welcome to Algebra 2 Test Section 2 on exponential functions. All right, so we just want to solve each equation. So we're going to take a look at 1 over 81. This is raised to the power of negative 2r plus 1. This is equal to 9 raised to the power of 2r. So the idea here is to have the same base on each side. So I think the easiest thing to do would be to have the same base of 9 on each side. So what could I do to rewrite 1 over 81 as a number in exponent form with a base of 9? Well, I could use 9 to the power of negative 2. Right, so if I had 9 to the power of negative 2, this is equal to 1 over 9 squared, which is equal to 1 over 81. So if I rewrite what's inside of parentheses here as 9 to the power of negative 2, remember this guy right here, this exponent, has to multiply this guy right here. It's got to multiply the whole thing, so we're going to use some parentheses. So 9 raised to the power of negative 2 times the quantity, negative 2r plus 1. And this guy is equal to 9 raised to the power of 2r. All right, so you'd have 9 raised to the power of negative 2 times negative 2r is 4r. And then negative 2 times 1 is minus 2. And this is equal to 9 raised to the power of 2r. Now, once you have the same base, I have a base of 9 and a base of 9, you can just set the exponents equal to each other, and you can just solve. So in other words, I can take 4r minus 2, that exponent there, and I could set it equal to 2r, that exponent there. So to solve this, I would add 2 to both sides of the equation. That'll cancel. I would subtract 2r away from each side of the equation. That'll cancel. And so 4r minus 2r is 2r. This is equal to 2. Divide both sides of the equation by 2. And so this would cancel with this. I would have r is equal to 2 over 2 is 1. So in solution set notation, I'll just put a 1 inside of set braces. Now, For the interest of time, I'm not going to check these, but if you wanted to, just plug a 1 in everywhere you see an R in the original equation and just verify that the left and the right side are equal. All right, let's take a look at another one. So we have 125 raised to the power of 3 minus x. This is equal to 25. So for this one, obviously 125, most of you know at this point that's 5 cubed. For 25, most of you know that's 5 squared. Again, if you don't know these things off the top of your head, you can always take the numbers and factor them and see what base you want to use. So to use the base of 5, I would say this is 5 cubed. And again, that 3 there is going to multiply this guy right here. So I've got to use parentheses. So 5 raised to the power of 3 times 3 minus x. And this equals 25, we're going to write as 5 squared. To simplify further, we'd have 5 raised to the power of 3 times 3, which is 9, minus 3 times x, which is 3x. Then this equals 5 squared. So now we have the same base. I have a base of 5 and a base of 5. So when this occurs, I can just set my exponents equal to each other and solve. So I can take 9 minus 3x, 9 minus 3x, and I can set that equal to the number 2. So let's subtract 9 away from each side of the equation. That'll cancel. We'll have negative 3x is equal to 2 minus 9 is negative 7. Let's divide both sides of the equation by negative 3. And so this will cancel with this. I'll have x is equal to, negative over negative is positive, so just 7/3. So in solution set notation, we'll just put 7/3 inside of some set braces. And so again, x equals 7/3 is your solution. If you want to check that, just plug a 7/3 in for x in the original equation, and you'll verify the left and the right side are equal. Hello and welcome to Algebra 2 Test Section 3 on exponential functions. All right, so we want to solve each equation. So we're going to take a look at 32 times 64 raised to the power of x minus 2 is equal to 8 raised to the power of 2x. So the idea here is to have the same base on each side of the equation, and then we can set our exponents equal to each other, and we can solve. So in order to do that, I want to just start by cleaning up the left side. And with 32 and 64, I can think about a common base of 2, right? 32 I could write as 2 to the 5th power. So then 64 I could think of as 2 to the 6th power. So times 2 to the 6th power. Now, this 2 to the 6th power, we have an exponent on that of x minus 2. So 6, this exponent would multiply the quantity x minus 2. Okay, then this equals 8 to the power of 2x. But again, we'll deal with this right side in a minute. So on the left side, I would simplify this. 6 times x is 6x. And then 6 times negative 2 is minus 12. So we would have 2 to the 5th power multiplied by 2 raised to the power of 6x minus 12. And again, this equals 8 to the power of 2x. All right, so now if I'm multiplying and I have the same base, I know the rule is to add the exponents. So with this guy right here, 2 would stay the same. I would add, you'd have 6x, nothing to really combine with that, but negative 12 plus 5, I could get negative 7. So this would be 2 to the power of 6x minus 7, and now this is equal to, how can I write 8 as having a common base of 2? Well, 8 is 2 cubed, so I could say this is 2 raised to the power of 3, and that 3 would multiply this 2x, right, that exponent. So 3 times 2x would be 6x, so this would be 2 to the power of 6x. Now, you're going to run into an equation here that isn't going to make any sense. You think about the left side here, you have 2 raised to the power of 6x minus 7, and it's equal to, on the right side, 2 raised to the power of 6x. How could that ever be true? It can't be. So you're going to run into an equation that has no solution. But just for the sake of completeness, we have the same base, so we'd set 6x minus 7 equal to 6x. Now, if I have something here and it's the same, I can get rid of it, right? 6x minus 6x, if I subtract that away from both sides of the equation, it would go away. So essentially, I could say minus 6x, this is gone, so that's a 0. And I would have negative 7 is equal to 0, which is nonsense. So again, you know when you get nonsense like that, you have no solution. No solution. Hello and welcome to Algebra 2 Test Section 4 on exponential functions. All right, we want to solve each equation. We're going to take a look at 216 raised to the power of x plus 3 multiplied by 36 raised to the power of negative 2x plus 1, and this equals 216. So the first thing I want to do is I want to clean up the left side of this guy, but the eventual goal is to get everything with a common base. That way the left side has some common base raised to some power. The right side is the same common base raised to some power. I can set the two exponents equal to each other, and I can solve. So 216 at this point, we should know that's 6 cubed. Again, if you didn't know that, you could just factor the number. So this is 6 cubed. And then again, this is raised to the power of x plus 3. So 3, that exponent will be multiplied by x plus 3, that quantity. And then we're multiplying this by 36 is 6 squared. So 6 raised to the power of 2. 2 is going to be multiplied by that exponent there of negative 2x plus 1. And this equals 216 again is 6 cubed. All right, so if we want to simplify here, we would say 6 is raised to the power of 3 times x, or 3x, plus 3 times 3, or 9, then times 6 is raised to the power of 2 times negative 2x, which is negative 4x, and then 2 times 1 is plus 2. Okay, then again, this equals 6 cubed. Now, if I am multiplying and I have the same base, we know we keep the base the same and we add the exponents. So for this guy right here, 6 stays the same, and I just add the exponents. So 3x minus 4x would be negative x. 9 plus 2 would be 11. So this is 6 raised to the power of negative x plus 11, and this equals 6 cubed. So I have the same base here on each side of the equation. So when that happens, I just want to set the exponents equal to each other and solve. So in other words, I would set up the equation negative x plus 11 is equal to 3. Right? This guy is equal to this guy. So to solve this, let's subtract 11 away from each side of the equation. We know that that would cancel. And if I drag this up here, I would have negative x is equal to 3 minus 11 is negative 8. I can divide both sides by negative 1 or multiply by negative 1, whatever you want to do. In the end, we'll have that x is equal to 8. Hello and welcome to Algebra 2 Test Section 5 on exponential functions. All right, so we want to solve each equation. We're going to take a look at 1/9 raised to the power of 1 minus 3x over 9 raised to the power of 2x. This is equal to 27 raised to the power of 3x plus 2. So the idea here is to get a common base on each side of the equation, and then to take the exponents, set them equal to each other, and solve. So we've got some cleaning up to do. On the left side, let's just think about the fact that if we had a common base of 9, we could simplify this guy. So 1/9, an easy way to write that with a base of 9 would be 9 to the power of negative 1. So you would have 9 to the power of negative 1. This would be raised to this. So power to power rule. Negative 1 would multiply the quantity 1 minus 3x. This would be over 9 to the power of 2x. Forget about this side for a minute. Let's just simplify this. Negative 1 times 1 is negative 1. So this would be 9 to the power of negative 1. And then negative 1 times negative 3x would be plus 3x. This is over 9 to the power of 2x. Now, let me just erase this real quick. If we're dividing and we have the same base, the rule is we can take the exponent in the numerator and we can subtract away the exponent in the denominator. So essentially I could say this is 9 raised to the power of negative 1 plus 3x. And then we're subtracting away 2x. So let's erase this. 3x minus 2x is x. So essentially I could say I have x minus 1 as my exponent. So this is 9 raised to the power of x minus 1. So this equals 27 raised to the power of 3x plus 2. Now the easiest thing to do here is to work with a base of 3, right? Because 9 is 3 squared, 27 is 3 cubed. Now you could make it work with 9 if you wanted to, but you'd have to use a fractional exponent, and that might add a little bit of complexity. So in order to just avoid that, let's just use 3 as the base. So this right here would be 3 squared. So I'd have 3 squared raised to the power of x minus 1. So 3 squared raised to the power of x minus 1. So power to power rule, 2 will multiply x minus 1, that quantity. This equals 27 is 3 cubed. So you'd have 3 cubed raised to the power of 3x plus 2. Power to power rule. 3 would multiply the quantity 3x plus 2. All right, let's get some room going. So we would have 3 raised to the power of 2 times x, which is 2x, minus 2 times 1 is 2. This equals 3 raised to the power of 3 times 3x is 9x, and then plus 3 times 2 is 6. So I've got the same base now. So the same base. So what I can do is just set the exponents equal to each other, and I can solve. So I would have 2x minus 2, right, this guy right here, is equal to 9x plus 6. So 9x plus 6. Add 2 to each side of the equation. That'll cancel. Subtract 9x away from each side of the equation. That'll cancel. So 2x minus 9x is negative 7x. This equals 6 plus 2 is 8. Divide both sides of the equation by negative 7. We'll have that x is equal to negative 8 sevenths. Or in solution set notation, we just put negative 8 sevenths inside of set braces.